Welcome to this third lesson in the teaching series on machine learning. In this lesson, we're going to create a self-driving car from scratch, in Scratch, and it's a super fun mini project which I hope you'll enjoy. Now, self-driving cars, really, I don't know, but to me they still seem like science fiction. I don't know if you've watched this movie from iRobot. It's based on a book written by the famous science fiction writer Isaac Asimov. Now, Asimov is thought by many to actually be something of a prophet. He made so many technological predictions in his books that have come true. Some very extraordinary ones as well. Now, interestingly, there's someone who seems to be quite taken with the idea of taking science fiction and turning it into reality. And that person is Elon Musk. You can look him up on Wikipedia. He's a huge business person, a businessman who started off by creating PayPal. He's the founder and chief designer of SpaceX. He's an early investor as well, and he's a product architect of Tesla. Now, a little known fact is Musk was bullied throughout his childhood. He was actually once hospitalized after a group of boys threw him down a flight of stairs. I'd love to know who those boys were. Now, an interesting point, and many of you might know this, is that he is now among, if not the, at the time of creating this video, one of the richest men in the world. But what is success? We're really quick to associate great wealth and fame with success, but it is worth mentioning, as a slightly cross-curricular consideration, that being successful at things that don't matter is actually a form of failure. So something you could ask yourself is, what does matter? And that's something for you to think about and answer for yourself. There's a lovely quote there by Francis Chan, wonderful author, and he says, "Our greatest fear should not be of failure, but of succeeding at things in life that don't really matter." If you look into Elon's personal life, he's had many difficulties, divorces, the death of his first son. Also read a report where he claimed to be working 120 hours a week, sleeping under his desk. Now, I don't want to speculate on his personal peace and his life's values, but it's always worth mentioning, especially to students, that money really isn't everything. Having said that, Elon Musk has contributed greatly to many charitable and educational causes, and he's doing much good in the world too. One of the things that we'll be looking at today is the self-driving car. One of the main tasks of any machine learning algorithm is the self-driving car. In the self-driving car is a continuous rendering of the surrounding environment and the prediction of possible changes to those surroundings. Now, what that means is you can take the self-driving car and you could divide it up into different subtasks. Object detection, and keep these things in mind as we go on to make our own self-driving car. Object localization and the prediction of movement. In this lesson, you're going to be drawing your own car in Scratch. If you feel confident with Scratch, you just need to listen for the next few slides and you can be off. Or I am going to actually take you through step by step doing this mini project. So you draw your car and you also draw your track. Now you can see that I've drawn a very complicated track. I would suggest you just drew a circle to begin with and then take it or make it more complicated from there. You're going to have two variables. One is going to be called right turn, or anything you like, something to identify that it is right turn, which can be set to 0 to start with, and turn left, which is also set to 0 to start with. This is the code for the car. It's telling it to move forward, and if you were doing this following the slides, I would suggest that you did 1 and 2 first, then you did 3, and then you did 4. You came back to 5 over here, and then finally 6 and 7 in the sensors. So you can pause the screen and come back to these 3 different things where you're going to be putting the code. This is the code for the car, this is the code for the left sensor, and this is the code for the right sensor. Now, it might not make much sense to you unless I explain it, so let's get into that and code this from scratch. So let's get started with creating our self-driving car, which is very exciting. And of course, you go to the Scratch website. I would highly recommend that you have signed up for an account, because that enables you to save your work, and click on create, and then you're back to your sort of project environment, and the first thing we're going to do is actually make a car. So I'm going to delete this sprite, and over here I'm going to choose the option to paint a sprite, which means I can make him or her, or in this case an it, myself. Now you can see the sprite's code, whatever it's going to be called. I'm going to call this car, is here, and the costumes is where you actually paint the car. I'll just show you that again in case I made it confusing. So you don't click on that, you click on the paint. You can call the car or the sprite whatever you like, and then here you draw the car. So I'm going to choose maybe black, and I'm going to draw a car. Just look something like that. I'm sure you'll do much better than this. Go draw a little wheel, and actually, to keep it consistent, I'm going to copy that 4 times and see if I can then move the wheels into position. So you can have some fun with this. You can also zoom into it so you can make it much more detailed. I don't want to spend too much time drawing, but you can see, you get the idea. Let's indicate where the top of this car is, so I'll just make a little arrow like that. That's the back of the car. Back. So we've got our car. That doesn't really look like a car, but like I said, I'm sure you will manage to do something much better than that. So you can zoom in and zoom out. Let's zoom back to the size that it is, so you can see there it is, and you can also change the size over here. So once you've done that, let's make the backdrop. So I'm going to click on, you could just choose, actually we're going to paint one because we want to make it specific, and I'm going to make the backdrop red. Let's increase this size to 40, I think that would be, or maybe a little bit bigger, 60. I'm just going to make a pretty simple 70, 80. That gives me a reasonable track. I'm just going to draw a track. Now again, you can make this as interesting or as uninteresting. You want to focus just on the coding as you like. I'm just going to make it a circular track for now, but do feel free to get as creative as you can. Of course, you can add little additional things to it, like a man standing there. Don't really know what these things are, but something. So once you've done that, you click out of it, and you can see you have a backdrop and you have a car. Now my car, if I was to move it, you can see it's a little bit big. To be honest, I can make it slightly smaller, so I'm going to make it 70 so it sort of fits. And this is the starting point of the track, so I'd like it to start over here. So let's start coding, and in the car, so remember you have the backdrop, you have the car, so you click on the car, and we're going to start with an event, which is when the flag is clicked, we would like to go to a specific position. And this is basically just positioning the car. So I'm going to say go to X, which is going to be a specific place, and you can see this gives me the coordinates of the car here, minus 187, so I'm going to change that to minus 187, and where's the car? Minus 55. And all that does is, if I move the car somewhere else, if I press the green flag, you see it returns to its initialized state. So the variables for the positioning of the car have been set here. I would also like it to be, when it's beginning, to point in a particular direction. So let's see if we can find that. Yep, point in direction. that's great, it's pointing in that direction. So if I change that, you can see how that would change as well. I'm now going to use a forever loop, which is great because we want to, whatever we put inside this loop is going to keep happening forever for the duration of this game. And go to motion, and I'm going to move it a couple of steps. Now you'll notice that that's going pretty fast. Move 10 steps. If I change that to 3, which could be helpful to begin with, it goes a little bit slower, and actually that's useful. It's nice. It's very satisfying. You have this moving car, but it's going off the track, so we need to do something about that. Now, in the forever loop, we've got it moving 3 steps. You can change that value to 1, which would make it go slower. And the next thing we're going to do is add an if-then loop. So we're not going to use an if-then else, it's going to be simple if-then right underneath the move 3 steps here. And we're going to ask it to do something. Now, think about what we're trying to do. You look at this car, it's going along, and we're trying to say, if it hits the left-hand side, if it touches the white, basically, we don't want it to touch the white because it means it's going off the track. So we'd like it to come back. And again, on the right-hand side, if it touches the white, we'd like it to come back. Now let me say that again. If the car's going along and it touches the left-hand side, we need some sort of sensor here, touches the white, we'd like it to turn right. So come back. If it's going along and the right-hand sensor touches the white bit, which means it's off the track, we'd like it to turn left and come back on the track and then move along. So how do we do this? Well, one of the things we're going to need is a sensor. But so let's come back to that, and first let's create the sensors. So in Scratch, again, we're going to actually make another sprite, and you can see this is sprite 2, and I'm going to call this left sensor. So left sensor, and I could make this any color I wanted. I'm just going to make it a tiny little dot like that, and you can see it's a bit big. I would prefer it just to be a little dot, so let's make it a little dot, and there we have it. It's a white little black dot. Now I'd like that black dot to be over here because it's going to be the left sensor of the car. So I'll show you how that's done in a minute. So we've created this left sensor. Let's go out of it and get back into the left sensor's code. And I'm going to add an event which says when the flag is clicked, again we want a forever loop because we want this to go on forever. And we want an if, then else in this case. So if this car sensor, which is still not attached to this, but I'll show you how that works in a minute, touches the white, we want something to happen. But first we need this little sensor to be attached to the car. So the way that's done, let's move this down to the bottom, is let's get another flag, another forever loop, and in motion we want it to go to the car. We also want it to point in a direction, so let's have a look to see if that is there. Point in direction, so let's add that. And what direction? Let's see if we have any options for direction in here. So this is where we find it. So it's a little bit confusing, and if you're doing this from scratch you might not be able to find it. But it's in sensing, and what you do is you select the car, which gives you different options over here. And you're trying to say direction of the car. So we would like to point in the direction of the car. And we also want to do a few more things. We want to really position it, so let's just see where it is. At the moment, I can see it somewhere, can't really make out. Now, I don't want it to get lost in there, so I'm just going to go back into it actually. And go into the costumes and make it yellow, so I can see it slightly more clearly. suppose that's slightly, you can see it, that it's been put in there, and you can see it slightly more clearly. So the dot is there. And it's tracking along with the car, but we don't want it to be just anywhere, we want it to be there, on the left hand side. So again, it's a little slightly complex, but once you get the hang of it, it's not too bad. Let's go into the sensors code, and I'm going to use a motion block to turn it, and we can play around with these turns and these moves to see what works best. But I could say turn it to, let's see what that does. And where do I want to move it? Now what happens if I put it to 60? You can see it's sort of like further on, and I don't want it so far. So I want it maybe, let's say 30. That looks pretty good. So you can see it's tracking with it now. Oops. And it could just go a little bit more to the left, perhaps. Let's go back into the sensor. So what would happen if I typed in? You can experiment with these numbers. That's the best way to do things, and that's great. That's really tracking on the left. So at the moment, that's pretty much set up, but it's not quite beginning at the right place. Or is it? So, yep, that looks pretty good. So it's set up. And the left sensor is set up. Now, once you know how to do that, the next bit is pretty simple. You just do exactly the same thing, but you do it for the right sensor. So I'm going to make a right sensor by, again, doing the same process. Paint, make a little dot, which hopefully can be seen. Go into the code of that dot, you can see it's here. We're in the right place, and we do exactly the same thing. Now I could actually just copy all this code, so you could just go duplicate, or actually, watch this, you can just kind of copy that into your second sprite, and it gives you a copy of that code. So if I go into sprite 2, squashed it up, but it is there. You can see I've just basically duplicated the code, and I want to call this right sensor. And I want to spell that right because I've called it something strange there. So left sensor and right sensor. This one is going to be slightly different again, so just make sure we're in the right place, we're in the right sensor, and we'd like it to again go to the car, which is fine, point in the direction of the car, but this time we'd like it to be on the right hand side, and it's not, it's on the left hand side. So let's adjust this, maybe see what happens if we put in, say, 16. And you're going to have to, you can see it's kind of there now, but not perfect. Maybe a bit more, 20. And do play around with these numbers so it works for you. And slightly more, maybe 35. Right. That's not perfect, and again you're going to have to play with it, especially if you're a perfectionist, but it's something, we've got something working there. So we've got a left sensor and a right sensor. Now I'm just going to be slightly picky, go back and make that 30, I think. And 20, say 25. Great. So we've got our car and we've got our sensors. Left sensor, right sensor, and car. Now at this point, let's go back to the beginning of our code, which is in the car, which is here, and let's think about what we want to happen. Now, if the car turns left, we want to turn, right? So if the car starts to turn left and it's hitting the white bit here, we want to turn, and in the same way if it goes and hits the white bit on the right hand side, we want it to turn so it remains on the track. So how do we do that? Well, first we need to set up two variables. One's going to be called, let's click variable turn left, and let's make another one called turn right turn, maybe. So we've got turn left and turn right, and it's blocking my little tree there, so I'll just move it out of the way, or maybe move it here. And you can see that the values have been set to 0. And what we're really trying to say is if turn left is equal to 0. So let's see if we can find a block which says that. Maybe this one. So if turn left is equal to 0, well, then it's fine. We don't want it to do anything. But if it turns to 1, we would like the car to turn. And we can decide what degree we want it to turn. For now, let's just say 45 degrees. And then we can have another if statement which says exactly the same thing. If turn right, go back to our variable turn right is equal to 1. Again, we want to turn 45 degrees, but this time the other direction. So let's go back there and say this way. Great, so we've got something happening there, but we haven't coded the sensors yet. So let's go back to the sensors and see what we need to do there. So this is the left sensor, which we haven't finished this bit. So I'm trying to say now, under what conditions would we turn this variable to 1? Well, that would be if the car touches the white, because that means it's gone off the track. So let's go look into the variables here. That's fine, and maybe sensing. And what we're really trying to say is if the touching color, aren't we? So if we drag that down here, and we say if the touching color of left sensor is white, and how do we choose the exact color? Because you might have drawn a different color, not have white as your background. That's quite cool. All you do is you click on this, and there's a little option where you can customize the color. You click on it, and you choose the color, and then come out of it. And you can see it's chosen the color that I selected. So if the touching color is white, then I would actually like to set my variable, which is in this case right turn, I think, because I'm in the left sensor, I hope. Yep. I would like it to turn that to 1. And otherwise, I would like to set right turn to 0. So in other words, if it's not touching the white, turn it back to 0. It's fine. It can just keep going on straight. That's great. So let's do exactly the same thing now with the right sensors. So we say if the touching color, so we go into looks or sensing. So if the touching color, and we choose the white, the exact color is white, then we would like to set two variables. We'd first of all like to set, remember this is the right sensor, so we'd like to set the turn left to 1 if it is touching, and if not, turn left, keep it to 0. Let's check out what's going on and see what we need to tweak and what's working so far. Oh, so it's doing a couple of really strange things. It's sort of working. It's kind of sensing when it's going off track and it's moving, you can see, but not perfectly. And here it's seeming to go a bit haywire when it touches that black bit. But it's sort of, it's doing it, but not perfectly. Now you can see when you can think about this, when you're doing your own project, how interesting it is. And the fact that if you really want to perfect this car's self-driving along this track, you might need additional sensors to make it really smooth, or you might need to look at the degrees to which it's turning. So what if I, at the moment, the degrees in which the sensor's, it says -20, that's the position of the sensor. Or I might want to change how much it's turning, make it slightly less dramatic, maybe 30 or 30. And you can experiment with these values. It's done something really strange then. That could be to do with this black thing which threw it off course, because we haven't coded in anything about obstacles, and that could be your next step as well. So I would encourage you at this point to, you're going to be doing your own one, so you're going to come up with these problems. And the solution is very simple. You're going to be looking at a couple of things, first of all look at the position of the sensors. The more accurate those are, the better it'll work. Also look at the car's degree to which it's turning when these conditions or these variables are turning to 1 or 0. Now again, that says if right turn is equal to 10, which seems to be a mistake. I think that's meant to be 1, isn't it? So let's change that and give it one last. Still going a bit crazy over there, and you can think about why. So a very interesting exercise. Hope you have some fun doing this, and particularly what I'd be interested in is if you could send your teacher or me a copy of a Scratch project that you've done with a beautifully, perfectly working car, self-driving along on a track without these glitches that I have. Remember, you can save your project, you can save it to your computer, you can save a copy, and you can also share. So do have a look at that, the options. So as mentioned, some extensions would be to get creative with the car and the track backgrounds, add some details, make it fun, make it more curvy. You could also create a more complicated track with twists and turns. Will your car still drive itself safely? And you can add additional sensors. And of course, the objective really of the game or the simulation is to get it smoothly driving on that track. The next lesson. Now, you may have heard of the great disaster that was the Titanic, or maybe you've watched that movie with Leo and Kate Winslet. What we're going to be doing is we're going to be looking at this context. Now, the RMS Titanic, it sank in the North Atlantic Ocean in 1912. It was on a voyage from Southampton to New York, and more than 1,500 of the 2,220 passengers and crew, they died when the ship sank. In the project, this is next lesson, you'll be making a program that can predict whether a specific passenger survived just based on their data, things like their name, well, not particularly their name, but their age, the number of siblings they had on board, what class they were they first class or third class, and you're going to use machine learning to train a predictive model using information about hundreds of examples of the passengers. So that's next lesson. See you then.